All right. So in our first question here, okay, we have a box that is lifted above ground level. Okay, 183 joules worth of work is done. What kind of energy did we change here? Potential energy, right, because we changed its height. It mentions nothing about an acceleration or any change in velocity. Okay, so we're looking for how high the box gets in question number 1. Okay, so give them a mark for their work is a change in potential energy / givens. Okay, that'll be kind of our first mark. Oh, you know what? I changed it. This is different. Sorry, it's a different question. Let's just do that here. Sorry, I forgot that I changed that question. Now the key is wrong. Okay, no problem. We'll do this. Okay, mark for givens. Mass, 8.5 kilograms. Work / change in potential energy, okay, is 183 joules. Okay, and we are looking for essentially the final height. All right, everybody okay with that? Okay, so 1 mark there. All right. This is a work energy theorem question. So work is a change in potential energy. Okay, so you can give them a mark for that. And we're going to say that work then is mghf minus mghi, except that we really don't need to write mghi because it's 0. Okay. So we have to manipulate this now in order to get hf by itself. So we're going to divide both sides by m times g. Okay, so if they have that the final height equals work over mg, or they've just plugged in the numbers, so 183 joules, okay, divided by 8.5 times 9.81, okay, that'll be their third mark, okay, if they either have it manipulated or numbers, whichever. Okay, and 183 okay, divided by, in brackets, 8.5 times 9.81. Not 85, 8.5. All right, so we're looking at, it'll get to a height of 2.19 meters. Pardon me? Yeah, I guess we give them full marks for being really, really lucky. Yeah, okay. So 4 marks. Any questions on number 1? Okay. Question number 2. Okay. I always do, just to indicate that there was a change, but you're right. I mean, I could have just done 183 equals mgh and I'd have got the right answer, right? Because I'd be calculating instantaneous like height at that point. Either way would work. Okay, so number 2, I got a soccer ball that has a mass of 0.75 kilograms, which seems kind of heavy for a soccer ball, but we'll go with that. Okay, and it's kicked from rest to a speed of 21 meters per second. How much work is done? Okay, so 1 mark for that. That's their givens. And you know what? We're actually going to say that this is out of 4, same as the first one. What kind of energy is changing here? Kinetic. All right, so my work will be the change in kinetic energy. So give them a mark if they recognize that. That's going to look like this. Work equals 1/2 mvf squared minus 1/2 mvi squared, but mvi squared is 0. Okay, so we are just looking for the work. Okay, so we don't even have to manipulate. We just have to plug in our numbers. 1/2 times 0.75 times 21 squared. Give them a mark if they got the numbers plugged in there. Okay, and our answer should come out to 165.38 joules. Fourth mark. All right. What did they round it to? Oh, that's fine. Yeah. Okay, so give them a mark out of 8. Let them see it. Pass it to the front of your row.